The goal of this tutorial is to present a simple algorithm for line following. Okay, this is going to be the outcome of the tutorial. So the line following robot is looking at the red line and using its vision sensors in order to follow it. In order to achieve this, what we'll do is first we'll create a path, this red line. Then our algorithm will be as simple as keep moving straight if both sensors see red, like it is shown here. And if one of them is not seeing red, then we'll turn in the direction such that we'll start seeing red. And that will help us achieve this. This video is going to pick up from the line following robot we developed earlier with vision sensors. Here, the line following robot is able to see the red background, and we were able to print the color, the intensity, and depth values. Okay, this particular file is in the description. You can download that and follow along. Okay, the first thing we'll do is we'll delete this plane. Select that, delete. Next, we'll go to add path, and we'll select open path. And the path is created here. Let's move that right in front of the line following robot. Okay, it's good enough. Now, if you want, you can actually change the size of this. Just click control point 1 and it is highlighted. Go to translate and then just move it around. Okay, here we're interested in a very short path, so let's just shrink it. Okay, now we need to create an extruded shape from this. So what you do here is click on these sidebars, say generate extruded shape. That changes the color to blue, but we want a red color. So I'll then click on shape, say adjust color, and then change this to red. Okay, now since we got that going, let's run this and then observe the left and right sensor. Here you can see that if we just move this slightly. So find tracer. Let's move it so that it is on the red line. Now run this, and you can see that it's not actually detecting the red color. That is because let's rotate this. You can see that the size of this path is pretty thick, and so it's not able to see the red line. So what we need to do is decrease the height of this path. So I'll select it here in shape, double click and say modify property. I believe it's along the x-axis because you can see the red is protruding out from the plane. Let's change this from 4 to 1, e -2, and now it has shrunk. Let's play this now. And you can see it's actually detecting the red line, which means you all set. Okay, now that we are able to detect the red line, now let's write the code which will keep this following the red line. Our goal here is so that both these line tracers, or the sensors, see the red line. Here only the left one is seeing the red line. So what we need to do here is, since the right one is not seeing the red, we need to speed up the right wheel so it'll turn in the counterclockwise direction, or slow down the left wheel, which will also turn in the counterclockwise direction. You can choose either of those two. So let's just do that. So let's open line tracer code. It's printing the values in sensing. We'll change the value here. So now we have an option of what to use. We can use, let's play this and pause it. Now I paused it just when the left sensor in the red line so that I can read off the values. So you can see that the intensity of the left sensor is 0.39. It's on the red. And the intensity of the floor is 0.75. So we can use this particular data value in order to differentiate red from the floor. If the intensity is less than 0.5, we know that we are seeing the red. If it is greater than 0.5, we know that we're seeing the floor. So first I'm going to create a variable called intensity left equals data left 11, which is this value, the first one printed. Intensity right equals data right. Okay. Now, first let's just run this. Stop and run. And we run this, we see that it gives an error. The error is that I attempted to value data left and it was returned a nil value. And the reason why this happens is because when this loop runs the first time, it calls actuation first and then the sensing. But when it calls actuation, it doesn't have access to data left because it's called in sensing. So what we need to do is we need to ignore the value of data left for the first call. So what I'll do here is I said if data left is not equal to nil, then do this. Okay, so what happens is the first time it's called data left is nil, it's not been defined, it will not execute this statement 16 and 17. It'll go sensing, it'll get the data value left, and next time when it's executed, it'll get the value. This doesn't really affect us. So let's run this, and now see it's fine. Okay, now since we got that going, let's now develop the logic. First of all, note that we've set both the wheels to move at the same speed. Now trying to develop the code which will tell it to turn left. Right? So what we do is if intensity right, that is this sensor is seeing a value which is 0.74, right? So it's greater than 0.5. Here it is greater than 0.5. And left is less than 0.5, which is here. Then what we need to do is print turn right. Okay. So what we need to do now is we need to speed up the right wheel. So let's take the right joint and speed. Okay, instead of having, so we have a lot of flexibility if we just change that to a variable. So what I'm going to do is I'm going to change that to variable. V equals 2, and I'm going to go to dv equals 2 also. Or let's call it 2 is fine. So let's this v. Now since this is to be sped up, it's v plus dv. And let's play this and see if it's actually turning towards the counterclockwise direction. There was an error. I did not close the ends. I need to close this because there's two ifs since I need two ends. Okay, now you see it's turned counterclockwise and it just keeps going because now it doesn't have logic to turn the other way. So let's just copy the same thing and do it for turning left. Okay, if intensity right, so change that to intensity left. This will be right. Turn left. Set target velocity of the left joint. Okay, let's try to run this. You can see it's getting subtracting itself. And eventually it keeps going. So we can run this again. You can see that here, you can right sensor is seeing, left sensor is sort of seeing it, so it's going to go straight. But now the left sensor is seeing nothing and right sensor is seeing red, so it's going to turn right. And then it uprights itself, and eventually here it is seeing both, so it just keeps going straight. Now we can just demonstrate this by increasing the length of that path. I'm going to stop this. Let's just choose the control point 2 and then just translate control point one. It's a straight path, but it's on an incline. Okay, and then when we run this, you can see that it's not actually seeing anything. So that's again because we need to modify the height. So if we go here, let's click this, that will be shape and say modify property. We change this to 1, apply. Okay, now let's see if it sees. So it's actually seeing, that's good. Let's rotate back. Okay, and now let's stop. Let's rotate it back and then play. So you can see it's turning right now. And now with both sensors are seeing it, so it just keep going straight. And they should turn a little bit right. Yeah, stop it here. We can also test it in this fashion. We'll rotate this about Z. Not quite. I need to respect to word frame. And then let's translate it. Somewhere here, so that's only one sensor is seeing the line, and then this runs. So you can see it's uprighting itself and it just keeps going straight. Okay, so that's how you do line following with some simple code.